Well, hello. Good morning, guys. Haven't seen you in a while. How you guys doing? Okay, sorry about last week. Hi Zian, how are you? Hi Nathan, hi Wing, hi Gary. Hey, Bashin. Right. Morning, guys. By the way, this is our June week one. Right. We are still in our own notes. By the way, we're still in our own notes. So yeah. So where were we? Okay, so where were we? About last week, right? I think I sent you guys the videos. So I hope you watched it. And if you didn't, then let me just quickly repeat what have we learned. Right, so guys, we have learned this last week, right? Basically, how to dry your clothes, right? We learned how to dry your clothes last week. So we learned about the evaporation of water. Okay, so how do you make evaporation faster? How do you increase the rate of reaction? How do you dry your clothes faster? This one very easy lah. Make sure you have low humidity. Okay, the air surrounding is very dry, low humidity, 潮湿度低. Okay, and then make sure your temperature is high. Make sure it's hot enough. You dry your clothes on a hot day. Okay, and then you have large surface area. You open your clothes and dry it. You don't just crumple it into a bunch. And movement of air is wind. Make sure you have a lot of movement of air. Okay, so that's the four factors. That's the four factors. With these four factors, your clothes should dry very fast. Okay, very dry air, very high temperature, very high surface area, a lot of wind. Okay, it should dry very fast. Okay, you guys cool? You guys cool? I hope you guys are okay with this. Really easy stuff. Okay. Anyway, let's go to today. Okay, this is what we are talking about today. Okay, this is what we are talking about today. Are you guys with me? Are you guys with me? You guys had your breakfast? You guys had your breakfast? I didn't have mine yet. Haven't had mine yet. I just woke up not long ago. Okay, good. Right, so guys, 5.2, solution and rate of solubility. We'll learn two things today. We'll learn what is solution first, and we'll learn what is solubility. Okay, anyway, let's talk about solution, shall we? Let's talk about solution. Okay, so what is a solution? What is a solution? Okay, when you take salt, all right, let's say salt. Okay, we take salt. Salt is what we call a solute. Okay, we call it a solute. It's the substance that dissolves in. Okay, please add an in here. There's a typo here. It's a substance that dissolves in other substance. When I dissolve in other substance, I'm the salt. You see, I'm salt, I dissolve in other substance. That means I melt, I dissolve away in other substance. Yes, it is, right? So when you add salt to water, all right, water is a solvent. Solvent, I dissolve other substances. You see, I dissolve away other substance. One is dissolved in, one is dissolved. Can you see the difference? Can you see the difference? So if I dissolve other substance, I'm water. All right. So when you have salt and water, solute and solvent, you will get salt water, which is a solution. Oh yeah, in BM, this is zat telarut, this is pelarut, and this is larutan. All right. So solution is the mixture. It's the mixture. When I mix it together already, this is how I get solution. Okay. Cool. Cool. Okay. Okay. Yes, Mingyan. Hello. Have I seen you before, Mingyan? If I have, then I'm sorry. Too many people. I can't remember the names. Right. So solute and solvent, you get solution. Solute and solvent, you will get solution. So salt water is a solution. Salt water is a solution. Why is it not called solute? I don't know. I don't know. That would be a very weird name, Gary. That would be a really weird name. So just remember this as solid. Solid, solute, solid, solute. This is how I remember. Because solvent and solute, everyone will just okay, it's okay. We just started not long ago. Which tutor are you from, Mingen? Are you from Yuqing or are you from Honey? Okay. Oh, you're from Yuqing. Okay, I see. Right, so solid and solvent, you get solution. Okay, so this is really easy. Guys, do not get this wrong in exam. For the love of God. Okay, so anyway, okay, let's talk about solution. We have three types of solution. Okay, so if you take a cup of water and you put just a little bit of salt, you will get something called a dilute solution. Okay, a dilute solution. You know it's dilute. Dilute means very, very watery. Okay, dilute means very watery, very not gao. You know it's gao, right? Very not gao. As in your Milo is not gao, right? They put very little powder. So less amount of solid and solid. You see, there's only very little salt. It's very not salty. It's very watery, right? So you can dissolve more solid. So dilute lah. This is called chai. Okay, chai. Next, what is concentrated? Concentrated is very gao lor. So you put a lot of salt. The water is really salty. The Milo is very gao. So you have more amount of solid. As you can see, oh, there's quite a lot of salt here. It's quite salty here. Okay, so this is pekat. Okay, pekat. As if we say gao lah. In Malaysia, we say gao. Then everyone understands. Right? So the last one, you have saturated. Okay, saturated. Saturated is tepu. This means full. You put so much salt that you cannot dissolve anymore, right? You have salt dissolved at the bottom. This is what we call an excess amount. Excess berlebihan. 多余 as in 多余 you have so much salt, the thing cannot dissolve anymore. It's like, okay, you take a cup of water, right? You scoop a cup of Milo powder and you put inside it. Right? Your Milo is not going to dissolve because it's so little water, and your Milo is gonna be so thick. Your mom will probably beat your ass lah, because Milo is really expensive, right? Okay, do you put? I don't think you put one cup. Even half a cup is a lot, right? But you put one cup out, wow, that's a lot of powder. Okay, you want to get diabetes before 40? You want to chop off your leg before 40? Please do it every day, right? So excess cannot dissolve anymore. It's already full. Saturated means full. Guys, saturated means full. Wow, that means one. There will be a lot of gains. Okay. So saturated. Okay. Do you know how do we use this word? Okay, we say this. The amount of doctors in Malaysia is already saturated. You see, in terms of English, this is how we use, right? This is what my friend said. Okay, my friend is a doctor. The medical field in Malaysia is saturated. Means full law, means there's not enough jobs law. There's too many doctors. Okay, you guys get me? Get me? So solution, you get dilute, concentrated, and saturated. Okay? Ken? Mingin, are you okay? Are you okay? Everyone okay? Is everyone with me? Guys, I know this is boring stuff lah. I understand. We have been playing with water for 3 weeks. Okay, because the first week, we've been talking about this, water stuff. Last week, we also talked about water. This week, water again. Guys, this whole chapter is about water, right? I mean, water is nothing to shout about lah. I understand lah. It's very boring stuff lah. But hey, this is easy in exam though. It's easy. It's boring, but it's easy. So it's like a trade-off lah. Okay, it's like a trade-off lah. Okay, you guys cool? You guys are not on a sleep, are you? Next week is your exam. Only 1, 2, 3. Usually the first exam only covers 1, 2, 3 lah. Usually it covers 1, 2, 3. Okay. You do if you missed last week's seminar, guys, If you missed last week's seminar, please come and get it from me. Okay, because I did revise on 1 and 2. Just want to wait. I think revise 1 and I just revised 1 and 2. If you need a revision, please let me know. Okay, shall we move on, guys? Shall we move on? Shall we move on? Yes. Okay. Cool. Cool. Okay, so let's move on, shall we? Let's move on. Okay, let's talk about this thing. Okay, I have a question here, guys. I have a question here. Can you do the same thing for sand? No, isn't it? You see? Why? Why not sand? Why not sand? You don't know. Because sand cannot dissolve, right? Okay, yes, that's good. Right? Sand cannot dissolve in water. Salt will disappear in water, but sand cannot disappear in water. Alright, sand cannot dissolve. Because sand cannot dissolve, lor. Okay, because sand cannot dissolve, No why. You think sand can disappear in water? No, right? Sand is just insoluble in water. That's the nature of it. Okay, that's the nature of it. Unless you smelt it, yes. Okay, anyway, so if sand cannot dissolve in water, right? If sand cannot dissolve water, but I put sand into water, right? I don't get a solution. Solution is when you can dissolve, right? When you cannot dissolve something, we call it a suspension. Ambayan. You know what is suspend? Suspend means hanging halfway. If I hang you with a string in air, you are suspended in air. 悬挂, you are suspended in air. Because you see, when you stir sand in water, they just kind of float. So we call it suspension. Right? We call it suspension. Okay? Okay, you cannot dissolve. That means this one cannot dissolve. Cannot dissolve in suspension. Okay? Most medicine is this. Most medicine is this. Okay, when you drink cough syrup, right? Cough syrup or the sore throat medicine, okay, it will say there, shake before use. Right? Why shake before use? Because if you don't shake this thing, suspension cannot dissolve, right? The thing will just kind of sink to the bottom. So all the medicine is at the bottom, right? They are not like solution. Solution no need to shake one. Solution no need to shake. Okay, guys, put it this way. Put it this way. If you let sand water sit, there for 3 hours, the sand will just go all the way to the bottom. Up will be clear, bottom will be sandy. Right? But salt water solution, no need to shake one. Salt water no need to shake one. You stir salt water, you get salt water, right? You put there for 3 days. Even after 3 days, it's still similarly salty everywhere. The whole cup still tastes similarly salty. So that's the thing about solution. All right, that's the thing about solution. Okay, so let's talk. Let's understand solution. Guys, salt water, right? Salt water, right? Do you have any color in it? When you dissolve salt in water, you get solution, right? Do you see any color? Do you see any color in solution? Like this? Clear, right? It is completely clear, right? No, it's not blurred. It's completely clear. It just looks like any cup of water. Guys, normal water and salt water, you wouldn't be able to tell just by looking at it. Theoretically speaking, okay? So it should be clear. It should be clear. Yeah, how to prank, that's a very lousy prank. Okay, so it is clear. It is uniform, means no need to stir. 均匀, no need to stir, right? It will be same everywhere. The particles are tiny. You can't see salt in salt water, right? You can't see salt. You can't see the salt floating there. No, it will be all gone. Since it is clear, right, it will allow light to pass through. Light can, if you shine a torchlight through salt water, the light will just go through fine, right? Guys, can you filter sand? Sorry, can you filter salt? When you have salt water, right? Can you filter salt water? You can't, right? So there will be no residue. No residue. You cannot filter salt water. You cannot just filter the sea and you get salt out. No. Right? So there's no residue. So like your salt solution, sugar solution. Okay, this is your solution, right? They are clear, no No color, none whatsoever. But let's look at suspension. This is the complete opposite. You see, suspension is like your sand water, right? They are cloudy. That means they look dirty. They don't look clear. And since they're not clear, they don't allow light to go through. They are not uniform. You need to stir them, right? Because they will sink to the bottom. Their particles are larger or can be seen. You can see particles in a suspension, right? And can you filter sand water? You certainly can, right? You have residue left on it. Okay, so like your sand water, mud water, oil in water, blood. Blood is a suspension. Blood is a suspension. Blood will sink to the bottom. Okay, you guys clear so far? You guys clear? Okay, I have a question here. Milo is which one? Milo is suspension or solution? Milo. Milo is a suspension. Milo is a suspension. Because Milo need to stir one, right? Because when you don't stir Milo, Milo will just sink to the bottom, isn't it? Milo will just sink to the bottom, isn't it? You just have the dark part at the bottom, and the top part will just look light, right? And it's just not uniform, okay? And it's cloudy, it's dirty. Light will not pass through Milo unless Milo chai. How chai you can you be? I mean, even very really chai, it's still a suspension lah, okay? Unless I've not drank really diluted Milo before lah. Not to the point that you can still light can go through it. All right. So question, guys. You guys okay so far? You guys okay? This part, guys, it is what it is lah. What you see here is what you get. There's no twist and turn here. There's nothing to explain here. It's straightforward as it can be. Right? But I have a question here though. I have another question, guys. I have another question. What about mayo? What about mayo? Is mayo a suspension or a solution? What about mayo, guys? What about mayo? Mayo is a solution or suspension. You see, mayo is really weird, right? Mayo is cloudy. Mayo is cloudy. It's dirty, right? Mayo light cannot go through, right? But mayo doesn't settle though. Mayo is uniform. You don't need to shake mayo one, right? And does mayo allow light through? No. No, not really. But can you filter mayo? No, you can't. So can you see it's like a half thing? Mayo is like a half solution and half suspension. That's why we call it colloid. This guy is like a pondan. It's like a pondan. It's not a guy, it's not a girl. So it's a colloid. Right? So mayo is exactly this way. Right? Mayo is exactly this way. They are uniform, just like your solution. They are small, okay, a little bit like your solution, but they are just like your suspension. Light cannot go through it, right? But they are also like your solution. They have no residue, so it's like a half thing, right? Mayo is like this, jelly is like this, shaving cream is like this. Can you see all these things are like milk? You don't need to shake it, but light cannot go through it. It's like a half thing. So that's your colloid. That is your colloid. So you have three here. You have three here. You have solution. You have colloid. You have suspension. Can easy stuff, huh? Easy stuff, huh? So you should be able to tell now, this is just about water here, right? Right. By the way, guys. By the way, this word, for the love of God, is pronounced as mayonnaise. Okay. Do not, I repeat, do not ever say mayonnaise. This is a pet peeve of mine. I really cannot tahan people who say mayonnaise. It's mayonnaise. Guys, N-A-I-S-E. If you use your common sense, you will pronounce it as naise. Right? How is this naise? Right? That's why, guys, the BM translation freaking suck donkey balls. How would you translate mayonnaise from mayonnaise? Okay. So no, it's mayonnaise, right? For the love of God, it's mayonnaise, right? It's just, guys, when you say mayonnaise, I know you're a freaking Gina. I know you're a Gina. You're a Gina who doesn't speak English, right? It's like this word, guys. It's not salmon. You know, every time I hear salmon, I freaking feel like I want to slap that guy. It's salmon. Yes, it's salmon. The L is silent. For God's sake, please don't say salmon. I will cringe. My ass, my butthole would pucker. Okay, I will cringe. I'll start cringing so hard that my toes will start scratching the floor. Guys, it's salmon. It's salmon. Salmon. It's freaking salmon. Right? Why is this only English class? Sorry. Right, guys, it's mayonnaise. It's mayonnaise. Okay, please, sir, can I have some mayonnaise, please? Right, do this the next time you go Subway. He probably doesn't understand lah, right? But how can any Subway worker understand things like this? Right? Or else they wouldn't be working in Subway. Ooh, right. Anyway, so let's talk about solubility. Let's talk about solubility. Right. So, how do you make your Milo dissolve faster, guys? How do you make your Milo dissolve faster? The key is to make your particle move faster. The key is to make your particle move faster. Right. So how do you make your particle move faster? How do you make your particle move faster? Number one, you increase your temperature. Okay, you increase your temperature. You use hot water. Yes, Kawhi, that's correct. Okay, you see, when you use hotter water, okay, it rhymes. Okay, if you use hotter water, the solid particle will move faster because hot what? So they move faster. Okay, so number one, high temperature. Number two, you would stir it. Right, the rate of stirring higher makes the particle move faster. Okay, so the solid particle move faster. Same thing. Next, if you are free enough, take a pestle and a mortar. Guys, you know it's a pestle and mortar. You are a true Chinese if you have this. Pestle and mortar. The thing you use to 种辣椒one. You know this thing? You know this thing? So you take your Milo powder, right? You put it here and then you grind it smaller before you make it, and your Milo should dissolve faster. Who even has time for this, isn't it? who will even 种 their Milo powder, right? You go and try, okay? You grind your Milo powder smaller, so that thankfully the thing will just dissolve faster. You try and see. Your grandmother got most old generation also got one. Right? So you would have smaller powder because smaller powder move faster, so they dissolve faster. So 3 ways to make your Milo. So lame, isn't it? Guys, this chapter is so lame, isn't it? It's all common sense. I mean, maybe this is slightly technical lah. Okay, your electrolysis is slightly technical lah, but the rest of it is just like, why are you telling us this, sir? Isn't this already common sense? Yeah, it is. Yeah, it is. Right? You just need to know the names of it. Yeah, exactly. So guys, anyway, water is what we call a universal solvent. Please know this word. They will ask this in the exam. This is called Larutan universal. Okay, guys, water is a universal solvent. You know why? Because water is able to dissolve like 90% of the things, right? Water can dissolve away dirt, can dissolve away sugar, can dissolve salt, can dissolve alcohol, can dissolve soap, right? Cleaning agents, things like that, right? So water is really good because water is a universal solvent. It can dissolve almost all substance, right? So what is the importance of water? Soft drinks are produced using water because soft drink has acid. Acid can dissolve in water. Water dissolve detergents. You can dissolve detergent in soap. Water is used to dissolve cleaning agent. Okay, soap again. Fertilizer can dissolve in salt in water because fertilizer is a salt. Traditional and modern liquid medicine prepare using water as a solvent. Okay, so water is good in dissolving 90% of the stuff. What about the other 10%? What about the other 10%? Guys, let's say you bought a new stuff, a new water bottle, let's say. The most annoying thing about the new water bottle is there's a freaking price tag on it. And usually price tag is really hard to come off. Isn't it? Guys, have you tried removing price tag? It is not, it is the least fun thing in the world, right? How do you remove it? How do you get rid of price tag? Even if you get rid of it, everybody get please. Okay, even if you get rid of it, there's this glue residue on it. It is really annoying to remove. Water doesn't remove it. I mean, it does lah. It's not very good at it lah. Isn't it? Isn't it? So what do you do? So what do you do? If you can't use glue, sorry, if you can't use water to remove the glue, what do you do? What do you do? Right, for that 10 remaining percent, to make your job easier, you would use something called an organic solvent. Right? An organic solvent. You know it's an organic solvent? Right. These things, they smell really bad. They smell really bad. Okay. For anything you cannot remove with water, you would use organic solvent. For example, let's say you get ink. Let's say you get some ink on your shirt, or you get some ink on your somewhere lah, you cannot remove lah. Okay, or let's say you get some pent ink on your plastic bottle. Very hard to remove, isn't it? So what do? You can use alcohol. Okay, you can use alcohol. Because alcohol is an organic solvent, what water cannot dissolve, alcohol can. So you just put your alcohol, you wipe it, the ink will be gone. That's why next time you get any ink on your shirt, alcohol is your friend. I mean, it doesn't fully remove it lah, but it's good enough, right? You remove most of it, right? By the way, alcohol is an antiseptic and a disinfectant. We use this to kill germs, right? It can dissolve perfumes and aftershave, right? So if you say alcohol is not strong enough, you want something stronger. Let's say you are painting your house. Let's say you're painting your house. You accidentally painted your plastic switch. You know, your light switch. You accidentally painted it. Now water cannot get it off. Even alcohol has difficulty removing it. So what do? Now you would use a paint thinner. Do you know what is a thinner? Do you know what is a thinner? In Cantonese, we say tina sui. Tina sui, yeah. Tina. We all say tina. Okay, it's what we call thinner actually. Thinner. This is what you would use to remove paint. Right? It's really, really strong. It's the same as kerosene actually. Okay, kerosene is also for paint, because it's basically the same thing. Guys, inside thinner you have kerosene. You have kerosene. It's one of the ingredients to make thinner. All right? Easy, easy. So next time if you cannot get your glue away from your new bottle, you would use this too. You can try alcohol. If alcohol doesn't work, you can try thinner. But I would advise against thinner because thinner is really strong and it smells really bad, right? What is thinner for, guys? What is thinner for? Let's say you painted your house during Chinese New Year. Your brush is now dirty. You want to clean your brush. You will use a thinner to clean your brush. Do you know that? Do you know that they use this in water in oil painting too, right? If you use your brush to do oil painting, and then now you're done with oil painting, and now your brush is full of the oil paint, you cannot get rid of it, you will use a thinner. Right? You will use a thinner. It's a really strong solvent. It is a very strong organic solvent. Right? But if you want something not so strong, you will use something called an acetone. An acetone. Now, what is this for? This is for girls one. Mostly they use this to remove nail polish. Nail polish. Because nail polish is also a kind of paint. Alright, they paint their nails, right? So if you have paint on your nails and you don't want to use thinner because thinner is really strong, it hurts your skin. So you use something called an acetone. This is slightly weaker, but it's still strong. Still strong. I mean, when your mom paints her nails, and she remove it, you can smell it. Isn't it? You can smell that nail polish stain from your mom. That's the acetone. That's the acetone you're smelling. Okay, that's the acetone you're smelling. The rest of it, ether, benzene, and chloroform, you don't need to know. Guys, you know what's the chloroform? You know what it's chloroform for? I mean, logical use, the correct usage is actually to melt plastic, but this is also the thing you use to kidnap someone. You know chloroform? You know chloroform? You know the thing they put it on their cloth and then when they 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 they, they put it in front of your mouth, that's how you faint. That's chloroform. Okay, anyway, so that's your chloroform. So you know what? I'm not gonna go too much today. I'm not gonna do too much today. I would rather let you do some exercise because if I go anything more than that, you might not even remember it that well. Okay, guys, shall we go to the exercise? Shall we go to the exercise? Shall we go to the exercise? Okay, I don't want to. You won't lah. Unless it's really strong lah. Unless it's really strong. Why? What do you want to do? What do you want to do? Okay, guys. You know what? Since we have a bit of time, right? Can I let you do some exercise? Can I let you do some exercise? Guys, can you please do question 5? Okay, if you didn't watch the replacement video last week, can you please do question 5? Can you please do question 7 and 8 and 9? Okay, 5, 7, 8, 9. 5, 7, 8, 9. I shall discuss with you later. 11, this one only lah. This is solubility. Okay, it's a bit too much. Okay, you know what? Please do 5, 7, 8, 9. Okay, 5, 7, 8, 9. I will give you maybe, is 10 minutes enough? Okay, 15. I'll give 15 minutes lah. I'll give you 15 minutes. I'll be back later to discuss with you the answer. Right? You guys okay? You guys okay? Are you guys with me? Nathan? Dian? Kai are you guys still with me? Mingyan? Okay, Okay, I cannot speak today. I will give you 15 minutes. Okay, I'll give you 15 minutes. Please do it right now. I will be right back. All right, are you guys done? Are you guys done? Okay, are you still there? Yes, huh? Okay, if you have done, then let's discuss the answer. Right, number 5. So evaporation of water. So the higher the humidity, that means the wetter the air is, the lower the evaporation. Okay, that means rainy day, you dry your clothes, it should dry slower. Right, the larger the surface area, the higher the evaporation. This is easy. C, movement of air will increase the rate of reaction. When there's more wind, there will be more evaporation. D, the higher the temperature of the surrounding, the higher the evaporation. Easy, huh? Easy, huh? Yeah, one more thing, huh? I did mention this in last week's video, huh? Evaporation is something that happens on the surface. Only on the surface. It's when the surface molecule, they get enough energy, they escape into the air. If you want to know lah. Right? So, next, number 7. Solvent is a substance that dissolves other substances. I dissolve someone else, I'm the liquid. Solvent. Solution is a mixture. Okay, solute is a substance that dissolves in. Can you see the in? Okay, when I jump into the water, I'm the salt. Right? And then suspended is solid that do not dissolve in water. Okay, as in the suspension. Next, number 1 is the solute, as in solid. 2 is the solvent. 3 is the solution. Okay, so what is the mixture? When you add flour into it, guys, flour cannot dissolve in water. Flour cannot dissolve in water, so this is a suspension. They actually give you a hint next question. You see, the mixture looks cloudy. Right, guys, why does the mixture look cloudy? What's your answer? Why is it cloudy? Why is it cloudy? What's your answer? Because flour is, yes, can't dissolve. Flour cannot dissolve in water. Okay, it can't be dissolved. Yes, can't dissolve. Yes, the keyword is dissolve. Right, so D, the particles of a suspension dissolve in the liquid. No, they don't. Particles of a suspension can be seen by naked eye. Can you see the particles of suspension? Yes, you can, because it's really, really big, like your sand. Deposited when left to stand for a while. Deposited means sink to the bottom. Yes, they do. Just like your Milo. Yes, okay, is the end good? Right, next. Match the following terms to the correct meaning. Concentrated solution is when you have large amount of solute. Solution is a uniform mixture. That means you don't need to stir. Solute is something that dissolves in. I jump into the water. Saturated solution is the solution that has the maximum. I cannot dissolve anything anymore. Suspension is when you have a non-homogeneous mixture. Okay, not uniform. Solvent is a substance that dissolve other substance. Dilute is when I have a small amount. Okay, cool, right? So B, the higher the stirring, I stir faster, the higher the solubility. The smaller the size, the higher the solubility. The higher the temperature, the higher the solubility. So easy, So easy, So number 9. Number 9, okay, this is challenging. Okay, number 1, this is a colloid. Why? Because you can't see through this thing, right? You cannot see through it, but you don't need to shake it. It's a half-half. Orange juice. Guys, funny enough, we have 3 colloids here. This is shaving cream. Shaving cream. Shaving cream is also a colloid, right? What about orange juice, guys? What about orange juice? What about orange juice? Okay, you see, orange juice has 2 answers. Orange juice has 2 answers. If you are talking about the pulp, you know the pulp? Okay, if you're talking about pulp, when you drink orange juice, you can taste the pulp, right? If you're talking about the pulp, it's a suspension because the pulp will sink to the bottom, isn't it? You need to stir the pulp so that it comes up, so that you can drink the pulp. But we are talking about, when you are talking just about the juice, it is a colloid, right? But for this case, I'm gonna write suspension lah. Okay, because we have so many colloids already, right? It's not a solution because light cannot go through it light cannot go through it. And what is this? Sugar water. This is a solution because sugar water is clear, right? So next, salad sauce. This is a colloid. Salad sauce is in the Thousand Island. Apple juice. Guys, apple juice can be colloid, can be solution, isn't it? Because apple juice is kind of clear. But it's not fully clear though. Okay, you know what? I can read this thing first. Okay, blood is a suspension. Blood is a suspension. Carbon dioxide and water is a suspension because the carbon dioxide will float on water. Doesn't really mix. Okay, water and chalk suspension also. Chalk cannot dissolve. Okay, you know what? We ignore D lah. This one won't come out lah. Milk is a colloid, right? And vinegar is definitely a solution because it's an acid. So apple juice. Yeah, that's why apple juice is brown. So you see, it's not really a solution. So it's a colloid, I guess. Oh, this is something for us to think about. I think apple juice is a colloid lah. Apple juice is a colloid lah because it's not really that transparent, but it's a bit transparent though. Yeah, you see, that's the challenge. Okay. Anyway, let's do one more, shall we? Let's do one more. Okay, Mary wants to sorry, number 11. May wants to find out if cocoa powder or cocoa cubes dissolve faster in hot water. She says her experiments as shown, right? List 4 variables that must be kept constant. What, 4? What are the 4 things you don't change here? You are only changing the cocoa, right? The powder and the cube, right? What else you don't change? Yes, the temperature, suhu. What else? Water. What about the water? Oh, you mean the solvent lah? Okay, the solvent. Okay, the pelarut. The volume of water can volume. The stirrer, or you can say the stirring, we have to stir the same rate. Both we have to stir the same. If one you stir faster, one you stir slower, of course it's not fair already lah, right? Because I'm only changing one thing. So number B, which beaker takes her less time to make chocolate drink? Explain your answer. Which one will dissolve faster? They will usually say A or B lah. Okay, so it's definitely gonna be B, right? Why? Because it has smaller solute size. Size zat telarut yang lebih kecil. How can her experiment setup be modified to determine how a higher temperature affects the rate of dissolving? How do you use the same experiment to test temperature? How? Both you put cocoa powder, okay, or cocoa cube lah, up to you. Cocoa powder in both beakers. Okay, so beaker A is 60 degrees. Bigger B is 30 degrees. Something like that. Something like that. Stirring still doesn't change. Water still doesn't change. Everything remains the same. You're only changing one thing when you do an experiment. Right? So May's mother is a food hawker. Ellie wants to help her mother to prepare. What? Choose Ellie or May. Right. What solvent is used to prepare the syrup? We can use water. How can May prepare the syrup faster? So what do you do? What do you do? There are three things you can do. Three things you can do. You can stir the syrup, use hot water, or okay, this one you cannot say size already because syrup is just the same size already. It's liquid already. Okay, so guys, I think I'm gonna stop here. Do you have any question? Do you have any question? Yeah, Wing Hei, what's up? Do you have any question? Easy, huh? This is really easy, huh? Next week I shall teach you how what is the thing again? Indoor water. How do they clean your water? Is tap water safe to drink, guys? Is tap water safe to drink? Can you drink water straight from the tap? Yes, you can actually. Right? Malaysian water is safe to drink. I'll tell that next week. Okay, I shall tell that next week. Okay, so I mean in Germany also, Malaysia also can. Okay, yeah, just the rust lah. Your water wouldn't taste very pleasant, right? I'll talk about that next week. So guys, have a good weekend. Okay, I shall see you next Saturday. Have a good one. I'll see you soon. Right, take care. See you guys. See you. Bye.